All right, in this video, we're going to compare the measures of center that we learned in class. So we learned three measures of center. Remember that we had the mean, which was basically the centroid or center of mass of the data set. Then we had the median, which was basically the middle number or the 50th percentile for the data set. And then we have the mode, which was just the most repeated value. So let's compare these and decide when we should use each. All right, so let's look at the mean versus the median, because both of these are suitable for numeric or quantitative data. So let's start with the mean. One of its strengths is that its sensitivity is great, right? In other words, if you have two data sets side by side that are identical, except for they have just one number different, right? Just one number different. In other words, say they were both, 100 values and 99 of their values were exactly the same, but they had one value that was different from each other. The mean for each of those data sets would be different, right? So it's that sensitive that even a slight change in one of the numbers produces some corresponding change in the mean. Now that's great, right? And that means that it really tells us and lets us distinguish between two different data sets. It helps us really understand kind of what's going on in a data set because it's so sensitive. On the other hand, its sensitivity can also be a weakness, right? So it's a weakness because extreme data values, especially if they're just on one side of the distribution, can have a dramatic effect on the value of the mean, right? So for example, think about, looking at personal wealth, and you look at somebody like Bill Gates in America being, averaged in with the rest of us. His personal wealth and people like him that have billions and billions really would make the average a little bit distorted. Now, I don't mean distorted in the sense that it's wrong. The calculation, of course, would be perfectly correct. However, when people think of measures of the center, they think of something that gives them an idea of what's happening in the data set typically, right? You're trying to think of, okay, where's the location of the data on the number line? In other words, roughly where do most of the values occur? We tend to think of it that way, right? So the mean is kind of giving us an idea of what's typical. Well, when you have these extreme numbers present, the mean starts to be somewhat misleading in that sense. In other words, it seems inflated if it's on the upper end. If the extreme values are on the lower end, it seems too low. And, it gives a false impression. So we would say in that case, maybe avoid using the mean and go for the median. Why? Because the median is insensitive, which is actually a bad thing, right? So what I mean by insensitive is, using that example we just talked about before, you could change a whole bunch of numbers in two different data sets and still keep the median exactly the same, right? For example, let's say I had test scores and let's say the median test score was a 70, right? And I found out that two top students in the class, they both earned 100s, and I found out they cheated. So I have to give them zeros. That would have very little impact on the median. And in fact, let's say if they had 65s on their test and they cheated and I gave them zeros, that would have no impact on the median if the median had been 70. Because, of course, if the median is 70, those 65s were already on the lower end and they still remain on the lower end when they become zeros and they don't have any impact on the median. Imagine in a class full of grades, if you gave two students zeros, what effect that would have on the mean. It would have a dramatic, significant effect on the mean, right? Depending on how many students, of course, but generally speaking, it's going to have a pretty important impact when you average two zeros into the grades. The median, though, doesn't get affected by that. So that's kind of a negative thing, right? It means it makes no distinction. It just sort of keeps plodding along the same way it always was. It takes a lot to move the median, right? There has to be a big difference between the two data sets for the median to be different. However, that downside is a plus at times. So the same way we could call it insensitive here, we can call it robust down here, and those things actually are really the same thing here. So robust means that the median kind of holds its ground even when there's extreme data values present, right? So imagine in that personal wealth example I gave you, Bill Gates' income doesn't really make that much of a difference there, right? Because it's just another number at the upper end of the distribution. The middle number, the number that's smack in the middle, the median, is still going to be the same whether Bill Gates loses 20 billion of his 80 billion, whatever he's got these days. Even if he loses 20 billion of it, he's still going to be on that upper end. It won't change anything, right? So the median is very robust. It kind of holds its ground. It's a measure that's not so sensitive to extreme values. And so when there is a danger of extreme values making the measure of the center seem unrepresentative, then we should probably use the median. Let's look at a couple of quick examples. Here's a great example where mean would work great. Male waist circumferences, I think these are for kids in high school. But either way, there's a physical limitation to male waist circumference, right? I mean, the human waist cannot get just infinitely large or dramatically large. In other words, somebody's waist circumference is not going to be 100 times larger than someone else's, right? Whereas if you're talking about personal wealth, it could certainly be 100 times larger, right? So because the physical limitations that exist, you probably aren't going to have these dramatic extreme numbers there. So probably the mean is going to be perfectly fine. And in fact, the better choice, because it's going to really reflect every nuance in the data, right? Because remember, it uses every single data value to produce the mean, right? So the process of calculating the mean incorporates all of the data. If you look at the median, however, this example would be perfect for it because we're looking at property values in a city. In this case, it's Deerfield Beach, Florida. And you can see that they range in this list from 174,000, and most of the data values are they're all larger than that, but they're not dramatically larger than that until we get to the last ones. And maybe this is a spot right on the beach. This home is $2.5 million, right? So 2,475,000 compared to the smallest one, which is just 174,000. And you notice there's nothing even close to that, nothing even in the millions. There's 450,000 in this random selection of home prices. There's just one home that's, maybe 20% the size of this, right? So the point is that this extreme number here is really going to, if you use an average, probably inflate the mean to something that's unrepresentative. It would give the impression that homes in Deerfield Beach have a much higher value or property value than they actually have. So in that case, probably it's best to use the median. And you'll hear the media do this, right? So when you listen to the news reports, you'll hear that when they're talking about incomes and property values and things like that, they tend to use the phrase median, right? If you're talking about, measurements like, things like human height or weight or et cetera, they're going to tend to use the mean. And so the media is trying to be responsible in the way they convey information. All right. So finally, the last thing to talk about, or the last measure to talk about, is the mode. What should we use it for? Well, I think, the mode is best suited for data that's at the qualitative level of measurement. Right? So nominal data, ordinal data, if you know what those things are, the mode can do that just fine. You might say something like, what color of car is most likely to get a speeding ticket, right? So you can collect data on that, and you could actually have a list that lists all the speeding tickets that were given and the color of car that was ticketed. And you might find that red is the most common color car to be ticketed on the highway. Maybe something about the color red attracts the police to it, and they're more likely to observe it or think that it's speeding, and they check it out and they find out it is, so they get tickets more often, right? Maybe that's the case. But either way, you wouldn't want to talk about the average car color that gets a ticket. That makes no sense. You can't add up car colors and divide by the number of car colors. And to talk about the middle car color, there's not even a way to kind of put them in order, right? And it's purely a nominal measurement, right? It's just, a name, right? This color is called red, right? So there's no way to put it in order of any sort. So there's no way you can use the median on it. So the only thing left is the mode, right? You have to use something like the mode. In this case, it's the most repeated value. The most repeated observation was red, so it becomes the mode, and it tells you what's typical, right? And that's the role of these measures of center, to give you an idea of what's typical, right? So typically, when you see a speeding ticket given to a car, the car is more likely to be red than anything else, right? Any other color. Okay, great. So the mode is great for qualitative data, let's say. Let's say for quantitative situations, you would want to use the mean or the median. And remember, you generally use the median only when you have extreme data values present that could potentially make the mean look sort of unrepresentative of what's actually going on.